This is why I took math. Calculus and Vectors Edition. Hi, I'm Brooke Blog, and I will be answering a question from the McGraw-Hill Ryerson textbook, section 3.2, page 164, number 14. Physics, a human cannonball. Let's get started. The height of the human cannonball is given by h at t equals negative 4.9 t squared plus 9.8 t plus 5, where h is the height in meters, t seconds after the cannonball is fired. Part A says, find the maximum and minimum heights during the first 2 seconds of flight. So, we start off with the h at t equation, which is negative 4.9 t squared plus 9.8 t plus 5. We now have to find the first derivative. Therefore, h prime at t equals 2 times negative 4.9 t plus 1 times 9.8 t plus 5 times 0. This is because while taking the derivative, you have to drop the exponent to the front and multiply it. So the squared exponent becomes a 2 and multiplies by the negative 4.9t, and the exponent of 9.8t is 1, so you drop the 1 down in front of the 9.8t, and the derivative of a constant is always 0, so 5 times 0. Therefore, the first derivative of the h at t equation is h prime at t equals negative 9.8t plus 9.8. Then, because we want to find the minimum and maximum heights, we need to set the derivative equal to 0 and solve for t. This is because at min and max heights, the slope will be 0. Therefore, we should set it to 0 to find out when the maximum and minimum heights occur. Therefore, 0 equals negative 9.8t plus 9.8. Then, 9.8t moves over to the other side of the equal sign, and you divide by 9.8 to equal t equals 1. Therefore, t is equal to 1 second at the maximum height. Then you substitute 1 into the original h at t equation to solve for the maximum height. So, h at 1 is equal to negative 4.9 times 1 squared plus 9.8 times 1 plus 5, which equals negative 4.9 plus 9.8 plus 5, which equals 9.9. So therefore, the maximum height is 9.9 meters at 1 second. To solve for the minimum heights, you substitute 0 and 2 in because the range is within the first 2 seconds. So h at 0 equals negative 4.9 times 0 squared plus 9.8 times 0 plus 5, which equals 5. h at 2 equals negative 4.9 times 2 squared plus 9.8 times 2 plus 5, which also equals 5. So therefore, the minimum height is 5 meters at both 0 and 2 seconds. Part C asks us to describe techniques other than using derivatives or graphing technology that could be used to answer Part A. Another technique would be to complete the square, which we learned in grade 10. The range is 0 is less than or equal to x, which is less than or equal to 2. Therefore, the original h at t equation is negative 4.9 t squared plus 9.8 t plus 5. Then, to complete the square, you factor out a negative 4.9, so you get negative 4.9 t squared minus 2t plus 5. Then, to balance out the equation, you add 1 minus 1, so you get negative 4.9 t squared minus 2t plus 1 minus 1 plus 5. Then, you drag out the negative 1, but you have to remember to multiply it by the negative 4.9. So you get negative 4.9 bracket t squared minus 2t plus 1 bracket plus 5 plus 4.9. Then you get negative 4.9 bracket t squared minus 2t plus 1 bracket plus 9.9. Then the overall completed the square equation is negative 4.9 bracket t minus 1 bracket squared plus 9.9. Therefore, the maximum height will be 9.9 meters. To find the minimum heights, you just sub in 0 and 2 into the h at t equation. So h at 0 equals negative 4.9 bracket 0 minus 1 squared plus 9.9, which equals 5. And the h at 2 is negative 4.9 bracket 2 minus 1 bracket squared plus 9.9, which also equals 5. So therefore, the minimum height is 5 meters at 0 and 2 seconds. So this technique, other than using derivatives or graphing technologies, will give us the exact same answer as part A. Since part C asked us for techniques, plural, another way to solve is through quadratic formula. So we start off with our original h at t equation, negative 4.9t squared plus 9.8t plus 5. Then we get our a, b, and c values, a negative 4.9, b 9.8, and c 5. Then we plug it into our quadratic formula, which is negative b plus or minus the root of b squared minus 4ac all over 2a. So then we get negative 9.8 plus or minus the root of 9.8 squared minus 4 times negative 4.9 times 5 all over 2 times negative 4.9. That reduces to negative 9.8 plus or minus the root of 194.04 all over negative 9.8. Then we split it up into two different equations, the plus and minus side. So on the plus side, it is negative 9.8 plus 13.93 all over negative 9.8, which gives us negative 0.42. On the negative side, it is negative 9.8 minus 13.93 all over negative 9.8, which gives us 2.42. These values are our zeros, and if you want to find the midpoint, you have to look at this. So you do negative 0.42 plus 2.42 all over 2, which by coincidence gives us a midpoint of 1. Then, when we plug our midpoint value, which is 1, back into our h at t equation, we get negative 4.9 times 1 squared plus 9.8 times 1 plus 5, which gives us 9.9. So the max height is 9.9 meters, which is coincidentally the exact same as part A. What is calculus? A method of calculation, especially one of several highly systematic methods of treating problems by a special system or algebraic notations as differential or integral calculus. This question fit into the calculus scope because we needed to use and find the derivative of an equation. Once the derivative was found, it was a quick and efficient way of solving for the answer, compared to the longer and older techniques I had mentioned before. The real world. Creating a human cannonball can be dangerous without knowing all the information. Stunters want to know when they will be in the air and how long for. Using calculus and physics, we are able to determine the correct heights and times the person will be in the air for safety. We would want to catch the person after being released, so knowing he or she will be at minimum height again, 0 seconds and whatever, we will be able to be there to catch the person. This is why knowing calculus and physics can be useful in the real world.